What's up, guys? I hope you guys are good. I've got a laptop repair that's a bit urgent, and I'm hoping it's easy. Anyways, this is a Dell laptop. It's a Latitude E5530. Anyways, when I plug a charger to this thing, it trips the power supply. Yep, you can hear that. That's the sound of the power supply tripping. Anyways, let me try to tilt towards the power supply. Okay, you can hear the fan for the power supply is already spinning. Anyways, when I plug a charger, okay, it starts drawing 5.1 amps. That is a dead shot to ground. Anyways, let's open up this thing and have a look inside. The customer is a local repair shop. They said their customer told them they spilled coffee on the device. One thing that I know by now is that always they'll say it was coffee, even though it was some nasty stuff. Anyways, liquid is liquid, but now we can't say liquid is liquid. Some liquids are more dangerous than others. I don't see any signs of liquid on the cover or even on the inside of the laptop. Perhaps it's underneath the keyboard. There goes the battery, no more screws. I need to take out the DVD ROM. I'm sure there's some screws underneath the DVD ROM. You can see the hard drive screw here. Another one there. There's a lot of screws inside. You know, these were really good laptops. When they were manufacturing these laptops, they were putting like their 100% effort into making a very good laptop, unlike nowadays. But then at the same time, these laptops are bulky. They are very, very bulky. So as you can see, I have to go through all this stuff. Yeah, when you disassemble these laptops, you get as much as at least 50 components, 50 parts, not components but parts. Like there's covers, there's whatever. If you add them up, you get a lot, you get a bunch. Someone has been here, 2 missing screws. That sucks. And that sucks a lot. Anyways, I'm not gonna rush to take out the network wires, but I know for sure the heatsink has to go if I want to get access to the motherboard, because the heatsink, it's holding on to the motherboard here and then it's clamping onto this plastic casing. So when you try to pull the motherboard from the top, it won't come out. So we might as well take it out now. Okay, this seems like the original CPU as well as the original heatsink, unless they took both from one laptop. Anyways, yeah, there are signs of the liquid now and the supposed coffee. There's 2 more screws down there. No, it's only one. Okay, cool, fair enough. Now let's go to the top side. The top side, we've got a, okay, let me try to zoom out there. On the top side we have got the keyboard, which comes out by popping off this plastic strip, and then you get screws over here, and the screws are missing. I can already tell there's one missing screw over here and another one there. I'm getting a feeling that I'm not going to enjoy this as much as I thought I would. put a screw there. Why? Because there's a screw, I guess. Anywho, here we are. We've got more screws. Yep. Like I said, these were intact and solid, but then they were bulky. A pain in the ass when you have to take it out. That's good. So coffee came from this side. The so-called coffee came from this side. I'm gonna liberate everyone from the motherboard. That's the power button, I guess. Cool. So let's check this out. And voila, we are on the motherboard. What do we see on the motherboard? We've got corrosion over here, corrosion around the EC. Funny enough, we've got no corrosion over there. Anywho, this kind of corrosion is not the one that's causing the laptop to trip the power supply. Of that, I am 100% sure. Okay, I'm gonna move it like this. So the corrosion we're talking about, it's quite areas. Okay, so there is the corrosion right over here. There. That area is corroded. And around the EC, there's not really corrosion. That's what I'm noticing. It's that kind of glue-like which will be on the plastic that comes on the top here. Yeah, someone took the plastic off and didn't put it back. I've posted a video where I did something like that and ended up breaking it. This plastic are not there for decoration. They do have a function. Okay. So let me check out the motherboard now. I'm gonna clean that corrosion, but what I know is that I'm heading towards the main power. The main power is what is the power that's going to cause a short on the main power is the one that will cause a 5 amp draw. If it was a secondary power, usually it would not be a direct short to ground. You would see like some pulses of a short on the power supply. The light for the short circuit will be going like and then off. Sometimes it does go on and just stays on. It just depends on how direct the short is, but yeah. If it's on the main power, it will most likely be the one that causes a 5 amp draw. That is a massive draw of current. Anyways, let me check out the charging port. How do you come out? So I'm excited to design such a complex thing. I wonder how long it took the person that designed the casing to do this. There's a person that does the casing, the same one that does the motherboard. What comes first? Because it's either someone designs a casing and then someone has to design a motherboard that fits into that casing, or is it that someone designs a motherboard and then they have to design a casing which can accommodate that motherboard? That one is an interesting point of view. And this is broken. Yeah, it's broken. There's a missing piece. I wonder where it goes. Anywho, all I want is this. Okay, let's come to reality now. So DC inject goes over here. That's the DC inject. if we follow it, we've got first inrush limiter, second one, and then a resistor over there. That's the most common trend that we get in these old versions of computers, or rather, if you want to say retro computers. That works too. I think no, these are not retro. Retro will be the Macintosh and stuff, and that's retro. Anyways, I'll check for a short on the main power, which starts on the second MOSFET, just on the resistor. So we do have a 0 ohm resistance on the other side and a 4.6 ohm resistance. So this resistor is okay for R7 there, that's okay. The resistor is fine there. That's the resistance of the resistor over there. But on this side we've got a short, a dead short, a 0 ohm. Yeah. So it shouldn't be like that. If you check the MOSFET, is it okay? This one is fine, and this one is also fine. So the MOSFETs are okay, but we've got a dead short. So all I'll do first is to clean this area, check on the motherboard if I've got no corrosion anywhere else. Nah, in terms of corrosion, okay. I wonder who opened this laptop and why they opened it, because this is very straightforward. I could see it without even having to do much. So yeah, I'm just gonna do this, try to clean off the corrosion with just the electronic cleaner. I have no idea what is inside that electronic cleaner. All I know it has to do with water. Okay, there goes our dead resistor over here. We will have to download a schematic later on to see, schematic or board view, to see what the resistor was doing. Because I just finished fixing 1 HP EliteBook. So it's 850G, what I have no idea, 450G, G8, G8 or G6, one of the two. Anyways, it wasn't charging, simply because the resistor was sitting but not sitting. It was sitting like this, but then underneath there was no connection, and therefore the laptop couldn't work. Check for that short. It is very healthy. It's got a very healthy short. So we will do voltage injection. Which we will use a short killer. Nothing fancy, it's just the same as the power supply, but then it's more direct. It just sends the required current and will burn whatever is there. So I'm injecting voltage. What am I drawing? 35 or 35 amps. There is no way a component is gonna heat up like that. This is a direct shot to ground. Something is literally linking to ground. Nothing's gonna heat up like this. Nothing will heat up like this. Oh yeah, I can clearly see it here. It's blown. It wasn't heating up. I'll be honest, it wasn't heating up. I just saw it. There was no heat at all. I can apply some flux if you want to see. Where is flux? My beautiful, my beautiful baby flux. That was a very mixed up statement. Anyways, I will apply it with. I'll spray it with. There. You can see nothing is melting there. Nothing at all. Otherwise, I can see this component right over here. Or this capacitor. Right, this one. And this one over here. I don't know if you can see the edge. It's a bit bent off. Yeah. We'll take that off the motherboard. Might as well take them both out. they're on the same spot, so I'm pretty sure at some point when this one was failing, the other one had to compensate. So yeah, probably not as healthy as it looks. Okay, come out now. Come out. The water is on low. I was working on a very tiny component yesterday, and I couldn't keep the heat up and I couldn't keep the air up as well. So I had to reduce that. Yes. Oh, what? The water is taking time to heat up. That's why I love the Yakusun one. As much as it died within a year, that thing I could just lift it from. I would just pick it up because it was an auto on and off. I would just pick it up and same time. And within seconds, it's boiling. Okay, our short still exists. However, we are guaranteed that this was a dead component there. So as you can see, when I'm testing the capacitor, it's got a 0 ohm resistance across. This was a dead cap. Yeah, it's clear, it's bent and all that. So that's probably the reason why the board was drawing so much current and nothing was heating up. There is probably 2 or 3 components directly linked to ground. Okay, we're still drawing the same amount of current, so I would assume the next one is dead. And these are related to the processor, so my guess is the MOSFETs, 1 or 2 are dead, and that has resulted in a dead CPU. Okay, this other one, is it okay? Yeah, this other one was fine. Not short, only the first one is dead. Okay, so what I'll do now, I'll take out the CPU. I'll take out the CPU and check if my short still exists. If it's gone, then it means I've got dead MOSFETs and probably a dead CPU. Ground, nah, the short is still there. This is gonna be fun. This is going to be fun. Okay, let's go where there was corrosion now and check for that short. Which we don't have a short where there was corrosion. Funny enough. Not at all. Not at all. Okay. No short here, no short there, no short there, no short over there, not there. This probably is no short, it's not the main power. This is not the main power, no short. So pretty much the secondary power rails are fine. It's only the primary power rail which has got a short. That's the funny thing now. Oh yeah, I took out the processor, so the short will be gone. Okay. Need to figure out where this short is coming from, because clearly it's not coming from a dead component. It's probably some trace which has directly gone to ground. Okay, there's a diode over there. No, that's fine. Another one here. It's okay. That's okay. Okay, I'll check the coils for a short. Oh yeah, the reason why I'm not going for voltage injection is that the short killer, the way it does is this: if I short the ground to the positive of the short killer on its own without putting any dead component on it, it will draw 35 amps. So what's happening is that when I'm putting it to the shorted power rail, it's immediately drawing 35 amps, which simply means it's directly linked to ground. It's not a dead component which is partially linking it to ground, but it is directly linked to ground. So that is a bit tricky to inject voltage because nothing is going to heat up. Nothing is going to heat up because it's just a direct short to ground. It's like the two power rails have already been meshed together. So yeah. Anywho, I will try again to inject that voltage. So we still have a 0 ohm resistance. Let me check the MOSFETs one by one. Then I'm probably going to get one that's dead. Where are the MOSFETs? No, that's fine. That is okay as well. That is also okay. These are fine. This is okay. This is okay. Yeah, we're okay. Fine. Okay. This one is fine. So is this one. And so is that one. So on the back we don't have any dead MOSFETs. This is okay. Has there ever been a more trickier shot to kill? This is going to the battery positive, so there's no way it's going to cause a short because it's only going to battery plus. Coming here to this MOSFETs, that's fine. That's fine. Huh. Okay. Okay. That's okay. So none of the MOSFETs are dead. Where is our short coming from? Do I have to take off everything now? Yeah, I pretty much have got something here. Nah, I wouldn't suspect anything to be dead over there. Those are the last two MOSFETs. And they are okay, both of them. So where is that short circuit coming from? I probably need a 10 amp short killer now. Clearly 5 amps is nothing to this power rail. Okay, what do I have over there? Yeah, I do have some corrosion right over here, but then it's not, there's no power rail over there, it's just some green goop, but no components around, so I don't think there's anything to do with my shot. Okay, shall I check it? And what do you know? That's okay, that's fine. So the shot was being caused by that green goop over there. Wow. But then there's no link to positive there. There's no link to the main power over there. Oh, it is. Yeah, there is a link over here. Oh, the shot is still there. The shot is still there. How did it disappear for a second? Okay, should I suspect that area? I guess I should. What connects over there anyways? Switching, oh, it's this guy over here. Why does it need a main power over there? It's coming to this. I don't think there's supposed to be a main power rail right over there. Okay, so we do have a short still. Because it's not even like 0 point something, it's like 0 ohms. What is this? Let me open up what's who downloaded Grammarly on my phone, on my WhatsApp, on my computer. Okay, let me try to inject that voltage once more. And what do we draw? Huh, wait a minute. I think my shot is not on the main power rail. My shot is on this power rail. Because there's MOSFET resistor, MOSFET resistor. Yeah, my shot is on the battery charging circuit. Yeah, let me confirm that. So we've got our charging dock coming here. We've got 2 inductors. Let's check those inductors to which component are they going. Are they going to this MOSFET or to that MOSFET? Because checking it over here, we've got MOSFET resistor, MOSFET resistor. So one of the two has to do with charging. One of the two has to do with charging the battery. So let us check. Our battery should have one side to positive and one side to negative. So this one, where is it going? Okay, this one is coming over here. So our short is on this resistor. Yes, 0 ohms. On this one we are fine. We don't have any short. So let us check now that incoming voltage from the charger. Where does it go to? From the charger, it goes to this MOSFET. Okay, so our inrush limiters are this one, and that resistor. So our power from the charger is coming from over here, of which we don't have a short over there. I don't know why we had a dead component also. So we've got a short on the main power rail, which we fixed by removing that cap. So by now, if I plug a charger, this thing should not trip the charger. Yep, it's not tripping the charger. So we fixed the short on the main power rail by removing that capacitor, but then we had another shorted power rail, which I didn't notice because they're pretty much the same design and one on the next to the other. So I didn't notice that I'm now probing on a different spot. Lucky enough I did anyways, because so now we should have 19 on one side, which is here coming to this MOSFET, and we should have ground on the other side. Nah, it's not a short. It is not a short. It's a buck converter. It's a buck converter. So you've got 2 MOSFETs. You've got 2 MOSFETs, one high side MOSFET and one low side MOSFET. So this is the low side of the MOSFET, and this is the high side of the MOSFET. So on the high side, there we go. We do not have a short. We are okay. That's the high side, and the high side is linked to the main power rail over there. And then this is the low side. That's why I've got ground. This resistor is not directly linked to here. There's a small capacitor over there. So this resistor is just working on its own, probably for checking the current draw from the battery and stuff like that. So this is the low side MOSFET, that's the high side MOSFET. There is no short on this laptop anymore. I can confidently plug a processor onto it and check for my short circuit. Okay, CPU is in. What's the status? Do we still have a short? No, we don't have a short, so we are okay. Now RAM, heat sink and fan is on the casing over there. Did I take it out? There was some screws to peg there to pleat with and ask them to release the fan. Okay, here's the fan. So I'm busy stressing myself with a laptop that's already fixed. Wow, I've wasted how many minutes? At least 20 minutes, I think. So this was fixed from the moment I removed that cap. Because if you remember, the second cap didn't have a shot. So all I was doing is I was probing on the wrong spot. I was probably probing on the wrong spot from the first point. Okay, plug it in, and there we go. We've got a fan spin. So this motherboard is fixed. It is working. So all I have to do is to grab a donor board and replace those caps because they have to do with the processor. So I'm sure at some point there's some stabilization issues. So this is not the exact same motherboard, but anyways, I do have the exact same motherboard. I'm just not gonna grab that one because I've got a lot of stuff in there. So trying to find that particular motherboard, it's gonna be an unnecessary bunch of drama. Anyways, we are replacing capacitors over there around the CPU power supply, so that will be here. Let's refresh the points over there. So that's why we were drawing 35 amps in the first place. I was injecting voltage on the wrong spot, so that's why it kept drawing 35 amps and nothing was heating up because I was applying that voltage to the wrong spot. And at the same time I managed to notice the dead component without having to take it out from the, without having to heat it up. It was quite clear that's a dead component. Anyways, let's replace it with these from this donor board. So I'm preferring to take this because it's a Dell motherboard as well. I do have a donor board like this, but it's a huge pile of donor boards in there. So having to start looking for the exact motherboard, it's really unnecessary. I can do it, but it's not necessary. Oh, I'm very much out of range. Okay, come here, my friend, come. There we go. Oh, my tweezer is sleeping. Is it my tweezer or the hot air is taking its time again? What is wrong with you? I decided to retire now. Okay, I probably need to buy another hot air for myself. I already have got 3 surrounding me. There's one there, there's the Axum, and there's this one. Wow, is this thing still working? Oh, let me just the airflow in it. It is still working. It's red hot inside, and I can't even point it on my face. Nah, that makes sense. That makes sense why it's taking time to heat up. And these cables are on a giant ground pad here, so the heat was just being distributed around. Oh, Lord. Okay, there goes one. And there goes two. So we can try to find a plastic, because I don't think I can confidently close this level like this, knowing very well that there was a plastic over here, and that plastic is gone. So I will probably cause a short to OK unnecessarily on the motherboard. It needs to be covered right over here before you put that top part. So yeah, that moment when I said the short has momentarily disappeared when I cleared this area, when I cleaned this place, I was probably probing over there and the short was gone anyways. So probably that's why the short appeared to have disappeared. Appeared to have disappeared. Some funny English I just spoke over there. Okay, if it doesn't restart, it's a dead RAM or non-compatible. It's drawing 700 milliamps, so now it's off. Because there's no CMOS battery, it's supposed to restart 3 times before displaying. That's the second round. We will expect it to go off again. Now it's drawing 800 milliamps. There we go. And Dell. Press F12. Boot options. Invalid configuration. Alert date and time. Alert the amount of system memory changed. AC adapter. Blah blah blah. This is fixed and working. Anyways, I hope you guys learned something. Gonna assemble this and then probably post a video of it when it's fully working. I've got a phone call from my bank, so I'm gonna stop from now. Cheers, thanks for watching.